Hi future doctors, welcome to the next class. In this class we will discuss about force and energy relation and condition for equilibrium. Relation between force and energy. So how we are going to get? So in this, to understand very simple way, I am taking an object at y1 distance. From here I have shifted to y2 distance. Now, what is the potential energy at y1 means? U1 is equal to minus mg y1. Gravitational force is acting downwards, displacement is upwards. Like this, U2 is equal to minus mg y2. Now, change in energy. Delta U equal to U2 minus U1. Minus mg y2 minus of minus mg y1. Then how much you will get? Minus mg if you are taking common, y2 minus y1. I am taking minus mg is common. So delta u equal to minus mg, this is going to be delta y. So this delta u only for our convenience, small change, du is equal to minus mg dy. So this one only they will write du by dy is equal to mg. Mg is nothing but gravitational force. F equal to minus du by dy. So potential energy is changing with respect to distance. This one only we will say F is equal to minus du by dr. If it is along x-axis or y-axis or z-axis, minus du by dx they will write fx. Fy is minus du by dy. Fz is minus du by dz. So this definition, energy is changing. Energy is changing with respect to distance. Whichever changing with respect to distance, that is called that gradient we will say. What is velocity gradient? Change in velocity with respect to distance. What is temperature gradient? Change in temperature with respect to distance. Now what is energy gradient means? Change in energy with respect to distance. But here negative sign is there. Therefore, negative energy gradient is nothing but force. Negative energy gradient is nothing but force we are going to say. If you are changing with respect to distance, if you are changing with respect to distance, that is your gradient we are going to say. So whichever is changing, which physical quantity is changing with respect to distance, that is that gradient simply. So this force they are going to write F bar is equal to Fx I cap plus Fy j cap plus Fz k cap. So they will give for you potential energy equation. They will ask what is the force. At the time you have to use this equation, very important equation, and from here you are going to get equilibrium condition also. So what is equilibrium? How many types of equilibriums will be there? We will see. So when this applied force is going to be 0, means F is equal to minus du by dr. If applied force is 0, if force is 0, du by dr is going to become 0. This is the condition for equilibrium. So how many types of equilibriums will be there for us? Means stable, unstable, and neutral. So these three are different equilibriums. So to understand this, so you have to come to know one concept which is very easy for us. So this is going to be, you can take one Pond's powder bottle you can take, or water bottle you can take. So after taking water bottle, let us assume this bottle if you are taking like this, I am applying force on this. After applying force, just I remove this. Then it may come like this. After so many oscillations, it will be coming for rest. This is called stable equilibrium. Okay. Now I am applying force. After applying force, I left this force. After leaving this force, it is not able to come upwards. It will be like this. Again, it will not come to its original position. Now this is called unstable equilibrium. After reaching this position, if you apply force in any direction, it will be like this only. It cannot be shifted. This is called neutral equilibrium. So if it is coming to same position after removing this force, this is called stable. After removing this force, if it is not coming to original position, means that is unstable, isn't it? After reaching one position, even though if you are applying or removing force, means it is not changing its original position, means that is going to be neutral equilibrium. So for this, generally they will give like this for us. So in a hemispherical bowl, one object is here. Now you are taking this object up to here. If you leave the force, then it will be oscillating, oscillating, oscillating. Finally, it will be coming here. This is called stable equilibrium. So same, if you are taking bowl like this, you are taking an object here. You have brought up to here. Here you remove the force. You remove the force means force is zero. Again, it will not come to here. It will be falling here. Then this is unstable equilibrium. Next, neutral equilibrium. So if this object is there, ball is there here. So after applying here, you removed force. In all the cases, you removed force. Then it will be here only, isn't it? How it is here, same like this, it will be there. That is called neutral equilibrium. So this is concept. But whenever we are giving problem, how we have to, whether it is stable, unstable, neutral. For all this, first you should apply where force is means at which position force we are going to make it 0. So problems we will discuss in our next video. This is the concept I am going to give. So they will give u is equal to xyz. Potential energy equal to xyz. So find the force at 0, 0, 0, 0, 0, 1, 1, 1, 1 position they will ask. At the time how we will do means f is equal to minus du by dx, f is equal to du by dy, fz equal to du by dz. So this du by dx only will call partial differentiation. Minus dou u by dou x, minus dou u by dou y, minus dou u by dou z, fx, fy, fz. After calculating all these, f bar is equal to fx I cap plus fy j cap plus fz k cap. So we will substitute all those values after partial differentiation. So all these problems in one video we are going to do, but this is the concept. Force and energy relation. Whenever they are giving energy, if they are asking force, means you have to differentiate them. Whenever they are giving force, if they are asking energy, you have to integrate them. Du is equal to minus fdr. So this one already we discussed. This is only work done equation. So therefore all relations will be interrelated. That we have to observe carefully that logic and we have to solve the problems. It will become easy for us at that time. Isn't it? Stable, unstable, neutral. So we will do problems in our next video. Thank you.